Well, here's the second video on section 6.1. I'm going to work out now problem number 28. I've got about, I don't know, maybe I'll get it right this time. Since I made a silly math mistake on 24 and then an even sillier arithmetic mistake on 18, let's see if I can do problem 28. Now, the main challenge to problem 28, the picture involves two parabolas, y equals 8x squared and y equals 3x squared. Of course, y equals 8x squared goes up a lot faster than y equals 3x squared, so that creates a gap between those two parabolas. And then we have a line, 4x plus y equals 4, that cuts down from the top. So I've taken the initiative to draw the graph previously. So here's the graph that we're going to work with. Now, this graph is not to scale. Those parabolas should be pretty close together, to be honest with you. I went ahead and found the x coordinates of the intersection points. To do that work, it's kind of tedious arithmetic. You have to solve, set each of those parabolas equal to the line. You end up with a quadratic. Both quadratics factor. You don't need the quadratic formula or anything like that. But we do get two rather interesting x coordinates for the intersection. We get x equals 1/2 and x equals 2/3. So when we go to integrate this, there are going to be quite a few fractions floating around. So we'll see if we can get this one to work out. Now, again, like the previous two videos I've given you, this problem requires a little bit of analysis in terms of how are we going to integrate. I'm definitely going to integrate with respect to x. I've already drawn my typical rectangles. You can see them, they're both black. And they're perpendicular to the x-axis, so that's going to allow me to integrate with respect to x. But like problem 18 and problem 24, I'm going to need two integrals, because the first integral goes from the orange parabola down to the blue parabola, and the second integral past x equals 1/2, that goes from the pink parabola down to the blue parabola. So when I do my top minus bottom for both of those, I'm going to have separate integrals. So my first integral is going to be the integral from x equals 0 to x equals 1/2. Top parabola is 8x squared minus the bottom. And in this case, the bottom parabola is 3x squared. So that's going to work out pretty nice. The second parabola, however, the second integral, that's going to have to be the integral from x equals 1/2 to x equals 2/3. And that's going to be the top graph, which is, I have to solve that for y. Right now it's 4x plus y equals 4. If I rewrite that, that becomes y equals 4 minus 4x. So that's going to be the quantity 4 minus 4x minus the bottom graph. Now the bottom graph there is the blue graph on my picture. The bottom graph would be the blue parabola. Pink to blue, top to bottom. So that's going to be minus 3x squared dx. So here is the integrals, excuse me, that are going to give us our area. And you can hit pause there if you want to take a look at that, see if you've got exactly the same integrals. Now when we simplify the first one, that's just going to be the integral from 0 to 1/2 of 5x squared dx. Plus, now the other one is the integral from 1/2 to 2/3. And if we rewrite that in descending powers of x, that's going to be minus 3x squared minus 4x plus 4 dx. Now, if we integrate those, the integral of 5x squared becomes 5x cubed over 3. Evaluated between 0 and 1/2. Plus, the integral of negative 3x squared is going to be negative 3x cubed over 3. So that's going to be negative 3x cubed all over 3. The integral of minus 4x is going to be minus 4x squared all over 2, and then plus 4x. We're going to evaluate that between 1/2 and 2/3. So this is what I got when I integrated. Now, plugging a half into the first integral, that becomes 5 over 3 times 1/2 cubed. 1/2 cubed is going to be 1/8. So that's going to be times 1/8. Plus, now we've got to plug in 2/3 here. Those negative, that 3 and the 3 cancel, so we've got negative, don't forget the negative sign, so we've got 2/3 cubed. 2/3 cubed is 8 over 27, right? 2 cubed is 8, 3 cubed is 27. So that's going to be negative 8 over 27. The 4 and the 2 cancel, leaving us a 2 on the top. So now we have minus 2/3 squared. 2/3 squared is 4/9 times 2 is 8/9. And don't forget the negative sign there. So we get minus 8/9. Now we got to put in 2/3 times 4. 2/3 times 4 is 8/3. So that's plus 8/3. Now we have to subtract whatever we get when we plug in a half. So remember, we only have x cubed with a minus sign out in front there. So a half cubed is an 8. So that's going to be minus the quantity, right? Because of the fundamental theorem of calculus, minus a quantity. And then our first entry there is going to be minus 1/8. Plugging a half into the next term, it's going to be minus 1/2 squared, that's 1/4, times 2. 1/4 times 2 is a half, so that's minus a half. And then a half times 4x is going to be plus 2. Now, if we were just to write this down, we have 5/24 for our first term, minus 8/27, minus 8/9, plus 8/3, plus 1/8, plus 1/2, minus 2. Well, there are some common denominator nightmares right there with that problem. So what I'm going to do is I'm going to pick and choose which terms I put together. For example, the terms with a 27, a 9, and a 3, I'm going to make those have a common denominator of 27. So I'm just going to put those 3 terms together with a common denominator of 27. The terms with the 24, the 8, and the 2, I'm going to put those together with a common denominator of 24. So that gives me 5 over 24. Now I'm going to go down and I'm going to pick off the 1/8. All right, I'm going to put that as a 24. So that's going to be plus 3 over 24. The half is going to be plus 12 over 24. And if we want, we can even put the negative 2 in there. But I'm just going to leave the negative 2 alone right now and leave that outside as minus 2. Now, I have a negative 8 over 27. But I have minus 8 over 9. Now, as a 27, I got to multiply top and the bottom by 3. So that's minus 24 over 27. And then I have plus 8/3. Now, again, I'm trying to get that over 27. So that's 9 on the top, 9 on the bottom. So that's plus 72 over 27. And don't forget our minus 2. Well, we have 5 plus 3 is 8, plus 12 is 20. So that gets us 20 over 24. Let's see, 5 plus 3 is 8 plus 12. Yes, that's 20 over 24. Now we have negative 8 and negative 24. Negative 8, negative 24, that's negative 32, plus 72. So that's negative 32 plus 72 is going to be 40. All right? 72 take away 30 is 42, take away the 2, 40. So that's going to be plus 40 over 27. And now I have minus 2. Now I need to get a common denominator between 24 and 27. 27 is 3 cubed, so I got 3 cubed there. 24 is 3 times 2 cubed. So basically I need to take 8 times 27. That's what I need for my common denominator. 27 times 8 is going to be a 6. Carry the 5. It's 16. 21. 216. Wow, that's not going to be pretty. Let's just take a look and see what they used in the answer book. Oh my goodness, look at that, 216. So, writing all these with a denominator of 216, 24 is going to go into 216 9 times. 9 times 20 is 180. So that's going to be 180 plus 27. Well, hello there, young man. Here, come in. Apparently we have a helper for today's lecture. This is Ruger. Ruger, come here. Come here. How are you? How are you? Do you want to say hello to anybody, or that's it? That was it? That was your entire contribution? Apparently Ruger's not much of a calculus dog. So 27 goes into 216. Let's see. 27 into 216 is going to leave me 216 divided by 27. You know, I think I have one of them there calculator things. No, maybe I don't. Oh, yeah, I do. 216 divided by 27. 8. So 8 times 40 is 320 over 216. Minus 216 times 2 is 432. Minus 432 over 216. So we have 180 plus 320. That's 500 minus 432. And I get 68 over 216. Let's see how we did there. Hey, we got one right. So that gets us 68 over 216, which reduces to 17 over 24. Is that right? 17 over 54. 17 over 54. All right, so I'll hold this up so you can take a look at the fractions. You can hit pause and see if you need any more. Where, let's see if we can get all of this in the screen at once. There we go. So that's a little bit better, isn't it? So that's a lot of fraction work there on problem number 28. So I'm going to close out here. That gives you a little bit of help. That's 18, 24, and 28. From there, you have a couple of calculator problems toward the end and some of the approximating rectangle problems in between 28 and 38. All right, I'll see everybody tomorrow in class. Do not forget, Chapter 5 test is Tuesday. Chapter 5 test is Tuesday. All right. Have a great night. Bye-bye.